Hello and welcome to Probot, Test Parallelization and Distribution with Docker and Kubernetes. My name is Merel Fukens and I am a Dutch software developer based in Norway. I think it's pretty cool that I can say I graduated thanks to Robot Framework. How did I manage this? Well, internships and particularly a graduation project were a vital part of my education. So when it was time for me to graduate, I was looking around for a project and I wanted to find a project that would really challenge my ability to adapt. So I eventually got in touch with someone from CGI Netherlands who told me that Robot Framework would be interested in partially mentoring an intern. When I heard this, I got really excited because I love open source. I think it is the backbone of software development, and I really wanted to contribute something. So they gave me a couple of projects to choose from, and this project stood out to me immediately as I didn't know Robot Framework or Docker or Kubernetes. So obviously that is the perfect project to do if you want to test your ability to adapt. So before I show you the design of the end product and a demo, I would like to talk about how I went about developing all of this. So before writing a single line of code, I wanted to do some research. Mainly, I wanted to figure out how do I go about splitting up these tests. After all, different users have different use cases, so I need to keep in mind all of these different people that may be using my tool. So I came up with 3 different splitting strategies where I would basically have 30 tests and I would assign them different properties. And the first algorithm is the tag split, which is to split up tests using their tag. The second algorithm is splitting up tests based on their execution time. And finally, I would split up tests randomly. We are looking for the longest running group per algorithm. And basically, that is not very surprising that if you split up your tests based on time and try to create even groups, splitting up based on time is the fastest. What I did think was a little bit surprising was that splitting up your tests randomly isn't necessarily the worst. But I figured that maybe the best way to go about splitting up these tests is to have a combination of all of these 3 strategies. So when I figured out how I wanted to go splitting up my tests, I went to work and I started developing the project. I had 2-week sprints, and at the end of every 2 weeks, I would show off my progress to Mani and Peter, and they would give me feedback and tell me things I could be doing better, and most importantly, what I could be focusing on next. So just a quick recap. This is what it looks like when you're running your tests normally without any parallelization or distribution. This is how the situation looks when you have parallelized your tests. And why do this with Docker and Kubernetes? It's so that you can very easily automate a lot of stuff. And such as your test runners, you can automate making sure that if one of your test runners goes down, you spin up another one, etc. So Docker and Kubernetes, I've mentioned it before, and I don't like assuming that just because you're watching this that you know what I'm talking about. So let me quickly explain what this is. So Docker is basically a wrapper around your code so that it can run anywhere, regardless of operating system or environment. The instructions to wrap your code is called a Docker file. The blueprint that Docker creates from the Docker file is called a Docker image. And finally, when you create an instantiation of your Docker image, it's called a Docker container. So what is Kubernetes? Kubernetes manages your Docker containers, and Kubernetes is built for failure. It assumes that something will break somewhere sometime. So if one of your Docker containers dies, no worries, Kubernetes will spin up another one. Please note that these explanations of Docker and Kubernetes are very quick and dirty, but they should be enough to help you follow along in case you didn't know what this was. So let me show you the result of all of my work. All right, so I start by starting all of my Kubernetes deployments. You can see here it created everything, and then it is good to go. So we can go over here and send all of my tests to a queue. So it shouldn't take that long, and there we go. As you can see, it created 8 groups. That is all of these over here. Keep the number 8 in mind because I will bring it up in just a second. Then we can have a bit of a look at this test suite. I am using the Robot Framework browser library. My IDE complains about it, but that's fine because it doesn't need to work locally. It needs to run in my Docker containers, and you'll see that it does. Other than that, I am using my own Python script, which is the script over here, and that also doesn't really do anything spectacular. These tests use my own keywords, and basically the point of these tests is to show you that the very basic robot framework functionalities work in my solution. So let's have a look and see if my tests are done already. So I will go to my host, and there we are. They are done. So let's open one up. Over here, we see 1 minute and 11 seconds. This is how long it would have taken for my tests to run sequentially. Over here, we see 40 seconds. This is the actual time it took for my tests to complete, which is a nice gain. So scrolling down a little bit and looking at these results, one test has failed. I wrote it specifically to fail, just to show you that I am actually running my tests and not just saying that it works. Over here, you can see that the keywords that I'm using are working just fine. And if we open up another one, we'll see that, let's get one where I do a little bit more interesting stuff. My own keywords work, the browser keywords work, and everything just works. It takes screenshots like it's supposed to, etc. So how does everything work? I showed you a lot of stuff, but that's okay. Just try to keep it in mind, and I will try to explain what I did here. So first, splitting up the tests. I am allowing users to define dependencies using a JSON file where they can make different groups. So in this case, D 1.1.2 has to wait for 1.1.1 to complete. Then you can also group tests together using tags. So test with grouping tag A will all be grouped together in the same group. Then when a dependency file was passed, we split these tests up in that way. Then you can also pass an output XML. This is just your standard robot output. And it is interesting to us because it has the elapsed time of tests. Estimation is hard in software development, so I'm taking the runtime of the previous test run, and I am trying to create even groups from those tests that are left over. We wanted to create even groups because, as I mentioned, if you have one really fast group and one really slow group, you're going to have to wait for the slow one before you can get all of your results. If we then have any tests left, this is something that happens if it is a new test, it hasn't been run before, and you haven't defined it in your dependency file, then we split up these tests randomly. So as you can see, all of the strategies that I found, that I used in my research, I am using. So that is just a splitting up strategy. How do we go from there? So after I create all of these groups, I send them to a RabbitMQ message queue. The queue sends messages to consumer containers, and these consumer containers send their result to an output volume. I may have been going a little bit fast there, so let me explain what I actually send. So my test suites are mounted into my consumers so that the most updated test will actually be run in the consumer. How, you may ask? So what I'm sending from the queue is just a string with the name of the test. The consumer recreates each test and makes it into a suite and runs that and sends the results to the output volume. You can have as many consumers as you want. I'm just using 3. The consumer also sends an acknowledge to let the queue know that tests have been run. Then the queue sends another message if there's any left. After all of the outputs have been generated, we run a log combiner container. This container just makes sure that all of the output files are put into one nice file and that all of the files are so that they can be in an output location so that you can see everything. But of course, I am missing the Kubernetes component here. Kubernetes is just in charge of all of this. And you can, if you want to, serve everything somewhere with Nginx. I picked Nginx. You don't have to use that. It's just what I picked. So then I would like to talk about a couple of properties. Namely, with the consumer, I would like to point out that it times out. I am doing this so that I can figure out which is the slowest consumer, and that is the number that I update in the output, so that you can see that nice 31 seconds instead of 1 minute 14. Then with the RabbitMQ message queue, it is a work queue. A work queue is useful for computationally heavy tasks. And one of the things that I think is really nice about it is that it uses round-robin dispatch to make sure that all of your consumers get a task. And it uses fair dispatch. So if a consumer is working on a heavy task that takes a while, it won't get another message until it is done. Finally, the RabbitMQ message queue has message durability. I've been told that some of you are pretty serious about your testing, so don't worry if one of your consumers fails or dies or something happens. RabbitMQ will notice this and put the message back into the queue, so no tests get untested. I would also like to talk about the Docker images that I am creating to run all of this. So first, I am creating a log combiner image. This is just a wrapper around rebot. Rebot is basically just combine all of your outputs. And it also puts all of the other files like screenshots and playwright logs into the location so you can see them. Then I have an RF browser and an RF Selenium image. These images just make sure that you can run the Robot Framework browser and Selenium libraries into your, you can use them in your tests. Finally, I have the consumer image, and the consumer image imports these RF Selenium or RF browser image. If you if you use Selenium and not browser, I got you covered. If you just have to change the RF browser image line in the Docker file to RF Selenium. And if you use neither, you just want to use the consumer, you just change it to a Python image. Then this is very much a proof of concept. It is not ready for production quite yet, but there are two features that I would like to add before. There are two features that I think this project would really benefit from. First is the dynamic scaling of consumer containers. You can imagine that if you have a couple of messages left in your queue and 100 consumers, that's kind of a waste of your resources. So I think it would be a great feature to add. Then I think having some kind of history file for your output XML would really help the time split algorithm. And this is because if a test has to wait for a really long time for whatever reason, it skews the runtime for the test very much. So I think it would help if you sort of, for each test, keep all of the output times and then use those to get the median so that you have a good approximation of how long your test is going to run. The final point I would like to make about this project is that this is a donation from CGI to Robot Framework. So this is an open source project, so you are free to fork it or open issues or clone it, whatever. It has the same license as Robot Framework, which is an Apache 2.0 license. Before I finish off, I would like to thank everyone from Robot Framework who has been interested in this project or helped me or something like that. In particular, I would like to thank Mani Kasiria, who has taken a lot of time to help me and has given me wonderful suggestions. And yeah, thank you so much, Mani. I would also like to thank CGI Netherlands for starting this initiative, and in particular Peter Wesseling, who was always pretty busy but always took time to help me. And I would also like to thank Erik Hendricks, who made this internship happen. Thank you so much. I hope you found this interesting. If you have any questions, feel free to message me on Slack or GitHub or LinkedIn. I hope you have a wonderful day, and I hope you have a wonderful RoboCon. Thank you.
All right, really cool session. Something I think everyone needs to know. Meryl's in the green room. We're about to go live. I think we have like 12 questions queued up, so let's do this. Hey, Meryl, welcome to RoboCon.
Hey, thank you.
Great to have you. Great session.
Yeah,
the last thing you
It
mentioned
was,
is you open source the solution. How did you convince your company to open source it? Is that something you led, or like how did you go about that?
yeah, so actually, this was an initiative from, I think, Peter Wessling and also from Mani. And I just got in touch with CGI and they said, like, hey, Robot Framework is interested in mentoring an intern
Oh, cool.
and this will be open source. So that's actually not for me to get credit on.
All right, very nice. Okay, let's jump into the first question. What are the advantages of using Docker or Kubernetes in comparison to Pobat Jenkins?
So the great thing about Kubernetes is that it's very scalable. So what I heard the problem of Pabot is that you can only run it on one single machine and you can't really distribute. And the great thing with Kubernetes is that you can just say, to, I want this to run on like 10 different machines. I want this to run on 20, 30, 100. That is really the power of Kubernetes, and that's you know why I made this project to sort of overcome the weakness of Pabot.
Nice. Tadu wants to know what was the biggest victory for you in this project?
Uh, I definitely think it was sort of making something with Docker and Kubernetes in the short time of like 5 months. And I think it's even less than that because I was also spending some time on research. So learning that and making like a full project, I sort of anticipated that maybe I can only get like the parallelization done or something like that. But the fact that I was able to make a full product was actually, I think that's the biggest victory.
That's very cool. Um, Ed wants to know, are there any limits on how many tests or how large of tests you could parallelize using your solution?
I don't see why there would be. You just give it like the best way I think to do it is to give it an output XML and then pass the dependency file if you have any dependencies, and you're good to go. You can throw in as many tests as you want, and then it's just the limitations of your own local machine, I guess. But I don't see any limitations.
Do you know, will this project be developed any further?
So the thing is that I would like to, but currently I'm not a tester and I don't use Robot Framework, unfortunately. So I don't have any time to work on this project. And it is a proof of concept. So I think it would maybe be better off sort of serving as a good example for other projects. But if there is a really big ask for it to be developed further, uh, that would be really interesting, and I would be happy to help make that happen.
Nice. What do you use to test then if you're developing? What do you use to test what you're developing on the back end?
We use like unit tests
Ah,
and PyTest in particular. But the sort of the testing at the site that I do it, it's like I don't know how well it lends for robot framework. And yeah,
cool. Have you tried your solution also with data-driven tests or data driver?
no, I haven't. There was only so much that I could do in those 5 months, so it's only very simple tests that don't really do all that much.
Do you know, is the code generated for this project publicly available, like by a
Yes,
GitHub?
it's on my GitHub. It's mwfukens/probot.
Awesome. If someone can drop that in GatherTown, that'd be a great resource for everyone as well. Awesome. Next question is, does splitting test suites with parallelization solve dependency conflicts in keywords files? If I run all my tests, they break halfway through.
I don't know if this person is already using my project, but I think if you because basically the way that it works is it reads from up to down. So if you have something defined at the very top of your file that will be grouped. And if you then define it somewhere else, or it has a tag that I mentioned, then it will be taken away. So it won't be picked anymore. So it will only run once.
Do you try or consider planning the test for running dynamically, i.e., whether a container is idle, sending another test to it for its execution?
Yeah, so this is actually something that RabbitMQ manages for me. It basically it sends one test at the time, and if that test or if that consumer is busy running, then it won't get another test. And if it's idle for a while and you have a new test in your queue, it will send another test to that consumer. And like I said, the scaling those containers dynamically, like turning it off if you don't have any messages left. I think that would be really useful, but unfortunately, it's not like a thing yet.
Do you know, for companies that are new or someone that's new to parallelization testing, what prerequisites or infrastructure would they need in place before adopting your solution?
Um, I mean, I definitely you want to have something for Kubernetes, right? So you don't want to host it on your own machines. I would say you would probably want to use something like AWS or Google Cloud Platform. And yeah, I would recommend not hosting it yourself, but like using one of those or yeah.
Okay. Do you have any troubleshooting tips you have for users that run into issues with test failures, logs, screenshots, other artifacts?
Um, I mean, I always use the good old debugger or the good old print.
Right.
So, if yeah, if something doesn't work, try to print it. Try to figure out where are my logs, where is this saved. I think that is like the best one I can give. I think it's also just like getting to know your tools, trying to understand what they do and where they do it, and yeah, I think that's the best tips I can give.
Nice. Why do you want to split up tests in groups that have an even execution time?
Yeah. So basically, if you have a couple of groups, right, and one of them is really fast, is done immediately, that you still have to wait for all of the other groups to be done before you can see all of your results. Now you could say, oh, you can just like spin up the result and send it to the user, but that's not a full picture of all of your tests. So you want to create even groups so that all of them finish around the same time. Then you run the log combiner, and then you have all of your tests in one report, and you know whether your software is good or not.
You may have addressed this somewhat. Have you challenged your approach against Selenium Grid and Pobot? I'm saying it wrong.
I haven't used Selenium all that much. I did try to include a little bit of it, but that was a challenge at the end of my project. So I was like, okay, I can only get a very small, um, like a very small sort of implementation of this. And but I haven't had the time.
Right.
That's really worked against me. Like the amount of time that I had was not enough to fully test this against something else.
So, parting words of advice, any suggestions on how to be successful with an internship? Because it seems like you really took advantage of it and it was, went really well. So, any thoughts on that?
I think what helped me a lot was be proactive
Mm.
and sort of, take initiative and say, like, hey, I made this, but is this good? Can it be better? How can I improve? I think sort of that drive for me has really helped me and this project. So honestly, be proactive, do what you can, ask around. Don't be afraid to get feedback or even criticism. It eventually it makes you a better developer and it makes you a better tester and a person.
Love it. Love it. Great advice and great way to end this session. Thank you so much, Meryl, for your awesomeness for contributing to RoboCon online. Appreciate you.
Yeah, thank
So,
you.
thank
Thank you
you.
for having me.
Cheers.